We're still investigating the data height versus right foot length, and we've drawn a scatter plot and identified some possible sources of outlier. We've applied the formula for outliers and determined that these two data points here and the data point down the bottom here are indeed outliers. So we're now going to remove them. I can remove the entire row by clicking on the row number in this left-hand column. That will include that entire row. If I want to click two at a time, I can hold the Shift key down and that will get rid of that one as well. I can then right-click anywhere in there and the option comes up to delete the selected rows. So I'm going to delete those two rows, and I'm going to come down and repeat that process for row number 9 and delete that row as well. If I now go down and have a look at what that's done to my scatter plot now looks a bit tidier. I've got a definite positive relationship happening here that looks much stronger than it was before. And I can go ahead and do some calculations and try to find if there's a relationship between those two variables. To do this, I need to do some calculations of the mean and the standard deviation and the correlation coefficients. I'm going to add an additional row down the bottom, and I'm going to put a label into cell E21. I'm going to call that the mean. My answer to the mean is going to go over here in cell D21, and it's a formula, so I'm going to begin with an equal sign. The statistical word for mean in this program is average. So if I start typing in the word average, it takes a good guess at what I'm after, and that's the one that I'm looking for there. I need to include all my data cells. I'm going to click on D17 and scroll up to include all my pieces of data, and then hit return, and my mean will be put down into this cell D21. I need to do that for the height data as well, but instead of re-entering the formula, if I hover over that cell that I just put the formula into, I can actually get it to turn into a yellow dot and click and drag that to the left, and it will apply that formula to the information to the left of it as well. You've got many decimal points here. You may not want all of them. If you come over to the right hand side over here, you can see that if you've clicked into the cell option, the decimal feature at the moment is on auto, and we actually want to make that a smaller number of decimal places. So I can click the up arrow and I can change that to required number of decimal places. We'll make it 3 for the time being. I also need the standard deviations. I'm going to add another row to the bottom and again make a label in cell E22, and that's going to be my standard deviation. Going to enter a formula into D22, so I click into D22 and press equals. There are two types of standard deviation. One of them is a sample standard deviation and the other is population. We only use population standard deviation in the General 2 course. So we're going to begin by typing standard deviation, and you'll notice that it's picked the one that we're after is standard dev. If you keep typing, it will give you the option of whether you want standard deviation A or P. We want P for population. So I'm going to click on standard deviation population, and if you get confused, there's always a list that will come up here in terms of functions. If you read over here, it tells you that it is the standard deviation based on their population variance. So that's the one that I want. So if I click on standard dev P, and now I have to enter the data that I want included. So I click again on D17 and I scroll all the way up to include all my pieces of data and hit return, and my standard deviation is dropped into here, and it's rounded to 3 decimal places because that's how I set the data up. If I hover over again that margin on the left hand side, I can drag and drop it to the data for height as well. So now I have all the information that I need in order to be able to do some calculations about mean and standard deviation, except for the correlation coefficient. So I'm going to calculate the correlation coefficient now. I'm going to create a label over here in F19, and I'm going to type correlation, and so that we can tell what that is looking for, we might make that a different color so it's easy to see. And my answer is going to go into G19, and I begin by typing equals because it's a formula. I know it's correlation, so if I type COR, it will have a guess and assume that you're looking for the correlation, which is correct. If I hit return, now you need to be very careful here. These go in the reverse order. It wants the Y values put in first and then the X values. My Y values was this column here, the arm span. So I'm going to drag and drop again from D17 all the way up to D3, and then when I click into Y, I'm going to drag, and I have to do it in the same order. You must go from the bottom to the top for both of them, or from the top to the bottom. So I'm going to drag up from the bottom up just because it's easier to do it that way, and then hit equals. Now if you think about what our scatter plot looked like, we thought there was going to be some kind of positive correlation in this relationship, and that's what this cell value has returned, a correlation that is 0.417. Got lots of decimal places on the back. I don't need all of those, so if I click into here and into cell, I can change that to something that may be a little more meaningful, 0.71, and that gives me the correlation coefficient for that line that you've got here. And that's how you go about getting all of the information: the mean for the X, the mean for the Y, standard deviation for X, standard deviation for Y, and the correlation coefficient that you will need to make your calculation for the line of least squares best fit. Now in an exam, if they ask you to show that the line of least squares best fit is a given line value, you must show all of the substitutions of these values into the appropriate formula. So we're not going to use the spreadsheet to calculate the gradient and the y-intercept, although you most definitely could, just like we did with the outliers, but it is much more important for your exam practice that you do it on pen and paper and show all your calculations. One last thing before we finish up, we might click onto the correlation here and change the color of that so it's easy to find all the data that you're after. And now what you need to do is take these four values here and the fifth value from here and drop them into one of the tables that you've practiced in class, and then show what equation you are going to derive for the line of least squares best fit.